Hello everybody and welcome to a chat from the engineering desk. Today we are going to be talking about using a MCP3424 I2C 18-bit 4-channel analog to digital converter with the Arduino, and we are going to transmit the data from 4 LM35s which I've got connected to it to a PC, and then graph the data that's being sent to the PC. So what we have over here is the MCP3424. We have one LM35 over here, and then over here is the other three on that little breadboard. And here's our Arduino Uno, and we've got 5 volts, 0 volts, analog 4 and 5 connected to the analog to digital converter. This is the I2C over here. On this board I've also got 2 pull-up resistors to 5 volts for the clock and data lines on the I2C, because you should have those on I2C buses. So there's 2 3K3 resistors on those buses to 5 volts. It can be 2K2 as well. Those are approximate values, but that'll work. So that's pretty much what's going on here in terms of hardware. This is reading the 4 LM35s in over here, other 3 over here, data out to the PC. So next let's have a look at what's going on with the PC software, where I capture the data so that can be used or be monitored, stored, done whatever with. In this case I am looking at implementing battery temperature monitoring on my UPS to detect when the battery is starting to overheat as it fails. So each battery will have an LM35 on it, and then there'll be an ambient temperature reading as well, and then the system will check for deviation and warn me that the battery is starting to run hotter than usual. This is prompted by a recent failure that I had, then necessitates this action. So I'll see you at the PC and we'll look at the software. Alright everyone, we are now at the PC. Let's have a look at this. I'm using Profilab to do the data capture. So this is the USB port where the data comes into the PC. There's a pulse generator over here that clocks it, and the data gets sampled in, and the data then gets displayed as a string. That's an indicator block. We'll look at the front panel in a moment. What then happens over here is that the string gets separated into the 4 values that have come in. That gets passed on to the 4 instruments and the digital displays. So you got the analog and digital displays. What also happens is it gets passed on to the plotter, and it gets passed on to the chart where the values are recorded along with the time and date stamp. This recording over here is also being clocked, and one can select how fast you want to do that. There's an on-off switch for the recording over here, and then there is a button that you push which clears the table. Over here I've taken one of the values. That's your temperature, you can see there, and you spy on the line. And over there I've got a value of 25, so if that value goes over 25, A is going to be bigger than B, so the red light is going to come on. So that's a simple comparative function, but how I would use it to indicate that I've got a problem, I would be comparing, that would be the ambient temperature that I'm feeding in there, and then I'd look at the individual battery temperatures over here and turn on a red light if there's a problem. Also on the graph I'll be able to see if the trend has been changing. And then over here one can look at the historical data, which has got time and date stamps. So let's have a look at the front plate. So this is what we got going over here. There's your 4 analog temperature gauges, and then you got your digital displays for each one. There's your incoming data, which is temperature, followed by a separator which is $sign. So that's your string that comes in from the Arduino. Over here, because I was fiddling around with the LM35, and we can see a bit of noise. Those are your temperatures. So that's being graphed. Then over here, if I want to export this data, I'm on Notepad, and there's our data, and I can then save that as a CSV file and export it and open it up in Excel. So if I go over here, and what did I call this video? Here we go. Let's call it history.csv. Now I'm going here. Open that up. We can close that as well. Having done that, Excel is going to open in a moment, then we can have a look at the values. And here we go. Comma separated values. And the other way to do it, depending on how you want to format your values for your spreadsheet, let's go back there. Yes, so I'm going to replace that. It should, in theory, now have separated it into columns. So here we go. So there's your timestamp, your date stamp. So if I insert a plot, there we go, there's our graph in Excel. Very good. So that's how you'd use the historical data from the table. Now, I think that pretty much sums up the GUI and the PC side of things. Let's have a quick look at the Arduino code. So down below is the Arduino code. Not a lot to it. You need the library for the MCP3424H. You need wire.h because it's a I2C. You then tell it the pin address for the MCP, I2C address. We need an array to store the results. So you got 4 values which are going to be reported back from the analog to digital converter. So you need an array for that. You then need to set up the serial port so that you can transmit data to the PC. So that's your void where you do that setup. In the loop, you have a loop where I gets counted up from 0 to 3. So you got 4 values for I. So when you read the MCP's values back over here, you tell it which from 0 to 3 values you want to read. 18-bit resolution. You got the gain set to 8. So that's your configuration data. So voltage I, voltage over here is your array into which the measure goes. So each time I increments over here, a measurement comes back for that position in the array, and you write it to the position in the array. You now need to send that out to the PC. So you serial print that value and you scale it because it's an 18-bit value. Now we're reading in microvolts as a result. The LM35 gives you 1 millivolt. Let me just make sure what that resolution is. 10 millivolts per degree C. Let me show you what that looks like. I'll quickly open up the PDF for you and see what the data sheet looks like. We may as well talk about that. Here we go. Hide that. So 10 millivolts per degree C is scaling. Half a degree C accuracy. It can level 4 volts to 30 volts. And here's the applications. So it's very simple to use. You put power on it, send the signal out to your analog to digital converter. Now as you can see here, it works down to minus 55. So if you want to read negative temperatures, you need to pull down from a negative rail to assist that value in going negative for negative temperatures. So you'd get a minus voltage out. Alright. Now the MCP, let's just have a look, see if I can find its datasheet. MCP 3424. Let's have a look what it says. Microchip, very good. Pin descriptions, let's talk about that quickly, because it has got differential inputs. So when you wire it up, you've got to reference them accordingly. Here we go. So differential input. So on my little setup, I've got channel minus connected to 0 volts, and the analog output from the LM35 is going to channel positive. Let's have a look at the, I did do a circuit diagram. So let's have a look at how it's connected. So being differential, you've got to connect them accordingly. It's not a single-ended input. Also, the range is, we got that package over there. The range, I think, is plus minus 3 volts. So the data that it sends does come with a sign. Let's have a look at the schematic. There we go. So there's the LM35. I've drawn something which represents the MCP3424 because I don't have a library item for it. So I modified something which is similar. So got 5 volts connected to it and the LM35. Ground is connected to MCP3424, and it is connected to the minus side of the A to D inputs. I'm in this case illustrating one sensor connected, but you'd multiply that by 4 for what I'm doing in my little project. So that's the drawing for that. And that's the LM35 and the MCP, all discussed. Put that away. So, having scaled that by dividing it by 10,000.0, I'm going to be receiving in a floating point value. I pause 250 milliseconds between transmissions, and then after each transmission I send the dollar separator. After it has done this 4 times, it exits here and it sends a new line which tells the PC software that was the end of the string. So let's have a look at how that works. So I'm going to turn that off. That purges the table, so you can see how that works. Now if you hit record again, it starts with a fresh plot and the table starts populating again with values. So that works. That's how that works. So I'm going to hit escape, which goes offline from the, it takes, this thing goes offline in other words. Now over here, go to properties. It's 4 values. The separator is a $. So that's how that part works. The string comes in like that. COM3, I've got it at 9600. 8 data bits, no parity, 1 stop bit. And here it's looking for the new line. So here it can tell the difference between the strings. So it receives in the string, and when it sees the new line, it turns that into a packet that it passes on to part. Part splits it up into the 4 analog values and sends it to the instruments for display. Sends it to the plotter and sends it to the recorder, the data logger in other words. That is pretty much what's going on there. So with this selected over here, pin status, when you hover over lines, you can actually see what's going on that line. So that's how you spy and debug in Profilab what's actually going on. So there you can see data coming in. Got the busy line. Look at the front plate. Back. And so there's the LED that indicates that we've got data coming from the Arduino. Those are displayed live, but that on account, sorry about that, of the on-off switch over here stops that from recording if you don't want it to record, but that's always being written to over there. So when I hover over it, you can see data. And I think that pretty much sums up this little talk. So after that, it's a printed new line. It goes back here and it starts the next 4 readings. So that's what's going on in the Arduino. Nice and simple. And there's that. So we hit record, data starts coming in. Channel 1, 2, 3, 4. There's the time and there's the date. Today's date. And it's late morning over here in South Africa. Very good. This is nice. I know this is a long video. I appreciate your time. Thanks for spending the time here to learn something, see something new. Hope it was interesting. I'd love it if you subscribe, like, comment below with your thoughts. And we will see you here for more videos. Cheers.